Hello, everybody. Hi, my name is JJ Asghar, and you are here to see building applications on Kubernetes. So I'm going to cover my slide or bring up my slides here in just a second. Normally, this is a much longer talk, but hopefully I can get this into the 20 minutes that we've allocated for it. And if you have any questions, I'm always available to help answer anything. So let's cut over now. And there we go. So let's talk about Kubernetes OpenShift in way too short of a time. Again, hi, JJ. I'm a developer advocate. I work at IBM. My email address is really awesome at ibm.com. And if you can find me on Twitter, at JJ Asghar. So again, I'm going to shoot right through these slides. Hopefully, it'll give you a nice little overview of what's going on. But I'm going to actually show you some code and how to push it out. Now, first thing first, I'm going to start with the very ground, the ground, and then bring it up from there. So let's talk about some building blocks. Basically, to understand the whole world of Kubernetes, you kind of need to start from the ground up. So let's go. First thing first, everything's built off of something called container. I recently found out that my marketing team, I'm not allowed to use a Docker logo, so that's why that's there. Hopefully somebody giggled at that. But the most important thing about cloud native development now is everything is built off something called a container. There are multiple different ways of offerings called Podman, Docker, Belda. There's also Kaneko. Everything should adhere to something called the OCI spec. You need some way to do it to contain or to register it. So that's what a container registry is. Docker Hub or Quay. Everything's built something called from a Docker file. And the beautiful part about containerization is that you package it. As long as you have the running container runtime, you can run it anywhere, which is great. So that whole story of your developer says, well, it worked on my laptop. If they containerized it, as long as they adhere to the OCI spec, anywhere it runs, it'll be able to run there. So as you start building up containers, you need a way to orchestrate it. And that's where Kubernetes is. Kubernetes is a container orchestration open source platform. If you actually look at what Kubernetes actually truly is, it's a very limited scope of what it does. It basically makes sure, and is a scheduler, to make sure that containers run across multiple nodes, which I'll talk about in a minute. They're quarterly minor releases, and there's no long-term support. It's all based off community support. There are some corporations, just like IBM, that have offerings that you can buy from, but there's no actual company at the end of it that is paid to do it. It's all run by open source people. You are, because of how limited the actual scope of Kubernetes is, if you ever go to landscape.cncf.io, you'll see how big the ecosystem is now, all the different things that are involved in getting Kubernetes. So it's really, really well worth it to know about this. But on that next step, that's where OpenShift comes into play. Believe it or not, OpenShift is actually Kubernetes, which is really, really cool. So you'll hear me use Kubernetes and OpenShift interchangeably because it really is. OpenShift is just some guardrails on top of Kubernetes, which allows you to get, as a developer, the velocity that you want to get your code out the door, which I will show here in a moment. Also, because it's Red Hat, there is actual enterprise support. There's actual engineers that are responsible for it. And then there's really nice abstractions on top of it. There's some very strong opinions and integrations. But the beauty of it is if you're just trying to figure out how to get this, it is a very natural way for engineers to work, which, again, I'll show in a moment. So when you look at a Kubernetes cluster, the most important thing you should know from the building blocks is something called a deployment. That's actually how you tell Kubernetes, I need N number of pods running. That's that deployment replica there, where A2 is. So when you give Kubernetes a command saying, I need this container or this pod to run, as you can see, you can have multiple containers inside of a pod. This will always make sure that Kubernetes or OpenShift is running N number of pods. In this case, 2 if you look at A. Then there's something called nodes. Nodes are the actual compute that runs Kubernetes or OpenShift. It can be a VM, it can be bare metal, it can be laptops, it can be even containers inside of containers. But if you are looking from this as a consumer, Kubernetes and OpenShift is just API to compute. if you start with that nugget of information and start building your understanding around Kubernetes around that, all of a sudden it makes a lot more sense. So if you tell, hey, OpenShift, go run my pod, and it'll find a node, schedule it, and put it on there, which is really, really nice. It's very, very, very strong. So be sure to put that around it. And if something breaks, something blows up, it looks for another node and immediately starts scheduling it to run there too. So let's talk about some internal concepts and terminology inside of Kubernetes and OpenShift. Because we're all engineers and we all like the internet, of course, there's a way to do DNS inside of Kubernetes. And that's actually how, that was supposed to be a joke. That's how intercommunication between pods work. So if I was in pod A over here on the right-hand side, if you can see my mouse, and I needed to talk to foo web, you create a service called foo web internally. This is internal to Kubernetes or OpenShift, and then you map it to the specific pod that you need to go to. So if pod A had to talk to foo web, did a REST call to it, or a put or a get or whatever, it goes to the internal kube DNS, and then it tells you where to go from that. So this is a really stripped down version of a YAML file, but in essence, that's all you really need, how you would map port 80 on foo web to port 5000 on this pod. The next important thing to know about is something called namespaces. Namespaces is the way to put walled gardens of your application inside of Kubernetes. So as you see here, they're two exactly the same, but one's called my application and one's called your application. So you can take the exact same manifests and be able to stamp it out, and they cannot talk to one another. That's really powerful. Okay, more advanced usage, yes, there are ways to break that, but when you're just learning, the best way to think about it is that they're completely walled gardens. That allows you to cut up your production Kubernetes cluster into dev, QA, and prod, and actually test on the same hardware in an isolated way of your code. So no longer do you have that machine for staging over sitting underneath your desk somewhere. Now you're actually doing it on the same hardware. That is unbelievably powerful when you start extrapolating, when you go from that. And you take it one step farther, OpenShift has actually made this super strong. They level something on top of it called projects, which is just namespaces with a different name, but it allows you to do some really cool development work as a downstream developer. You can almost think as projects as Git branches, where you can actually have n number of projects where you have RBAC in front of whatever you need. And if I was working on the payment dev here, for instance, I could actually do payment dev today's date, do a bunch of changes, see how it goes. If it works how I want it to, then I take those manifests and then I can promote them to wherever I need to go. Or I get those changes and then I make a new project and start over the next day. Projects are super powerful. It really works naturally with the development process of a modern day developer. The next thing you should know about are inside of the services, there are multiple different types of services. The one you will see mainly is something called a load balancer. They're just like load balancers that we do on the internet as a whole. There's millions of different ways and millions of dials and knobs to be able to play around with it. It can be an talk in itself. But I strongly suggest taking a look at it. You will see them everywhere. That's how you would, if you hit foo web, this is how you'd be able to talk to foo, the 5000 across whatever n number of pod Cs you have out there. You're only limited by your compute capacity of your cluster. Also, there are ways to actually rip out the load balancer and put other ones in now, which is pretty crazy. So it's a whole nother talk inside of itself, but it's important to know that this is the core way people interface with it. That's not 100% true. There's something called ingress, which is actually how you map your application from the outside in. This is a really bad example of one, but it kind of at least shows off what's going on. Where if you had this host sitting right here and you needed to hit slash, the ingress controller would say, oh, you're hitting foo web on slash. I need to go port 5000 here. But if I needed to go to slash data, and just like a normal router would have done, it'll actually go to foo web over here. So for instance, if I had this this container that needed to talk to foo data. When it asks the service, it would go and say, hey, where's foo data? Oh, it's over here, and then talk to what it needs to. Again, it's a really bad example, but that's actually how you wire things together. You end up spending a lot of time playing around with YAML and being able to wire this all together, which is one of the disadvantages of Kubernetes. But the crazy part is you take it one step farther, and that's where routes come into play from OpenShift. Routes are phenomenal. They literally turn that whole ingress controller into like 3 commands, which I'm about to show. So hopefully right here, I'm going to show off some really cool code now using OpenShift. So let's go look at a demo. All right. So first thing first, I'm on the IBM cloud, and excuse me, here is the OpenShift container platform, which is pretty cool. I have this code sitting here where I have an app.py. It literally says, well, right now, hello VMware code, because I did this in VMware code. What I'll do is I'll change it to hello world, and then we'll kick off a build and actually see it work. So let's see here. Let me verify that everything is in the state we want it to be in. Perfect. So what I'll do here is I will import from Git. I will take this URL right here, and we'll do HTTPS, copy this, and I'll throw this in here, paste that. Oops, I lost my window. Okay. And as you see, it's been validated. It already figured out that it was Python, which is pretty damn cool. We'll call it all that. That seems reasonable. It's going to be deployment. And yes, I'm going to want a create a route. That was that ingress that I was talking about a moment ago. Let's go ahead and create that. Uh-oh. So we already have something that exists called that. So let's go with another one. Why not? Sounds good to me. So I'll kick that off. Okay. So we come over here, and as you can see, it's already errored the pod because it needs to build it, but it's actually building it right here. So if I bring this up, we'll watch it build right here. This is pulled it directly from GitHub, now building it actually locally, which is now doing it. So we'll see here, let it go. And we'll see this one turn over here in a moment. Now, if you noticed here, it's port 8080. Oops, 8080. And I might purposely have done this, but if you look here at our app.py, we are actually on port 5000. So what we'll end up doing is we'll change the service, that service I was talking about, that foo web. We're going to change that internal service to port 5000 instead of port 80. So then we'll be able to see something. This is trying to kind of show everything going on here. So as you can see, there we go. We pushed it successfully in there, which is what we wanted. And now we are running this. So if I go ahead and click on this route, we get an error, but that's what we were expecting, right? So we can come, oops, over into this service. Over into this service. What I will do is I will edit this YAML. As you see, port 8080, so we want this to be port 5000. Port 5000. Oops. Port 5000. I will save that. All right. And now we come back over here. Oops. And then I will come into this route, and I will also edit this route to port 5000. There we go. Now we should see everything's running. So let's go ahead and click on that exact same link again. And there we go. We see hello VMware code. So cool. Got it deployed. That's exactly what I was hoping to see. But the most important, the next part, the thing that really convinced me as a developer to start taking Kubernetes and OpenShift seriously is the CI/CD. So let's go ahead and go back over here to, I believe it's this link. Yes, here we go. So already I can go into my example here, and I can build a webhook, right? So I take this webhook right here. I add a webhook, and I will grab this link right here with a secret because it's GitHub. Paste that in. I will change this to JSON, and then I will add this webhook. So now I'm telling GitHub, hey, whenever anything changes, kick that over there. And we already got a green check mark, which is great. Normally, if I had more time, I would do a little bit more verbose, but hopefully this is getting across to the point where I'm trying to make. So now, if I come over into our app PY, and I go ahead and edit this, and I'm going to edit it to hello world of nerds. Sure, why not, right? That works. So I go ahead and commit those change, push into master. I know that was wrong, I'm sorry. We can come back over here now and go back to our builds, and we should already, build number 2 is already kicking off. So by me hooking up inside of OpenShift to GitHub, as soon as that webhook kicked and it pushed to master, it went ahead and pushed it out. So now it'll go ahead and build this. Come on, build it. Again, this is CI/CD in its best way, right? So now it's creating it. It pushed it out already. Wow. Okay. So let's see if let's see if it works. Click on this. Hello, world of nerds. There we go. So I have this simple Python app that I've hooked up with CI/CD on top of OpenShift that quickly with webhooks and already got my changes done. Now, take a moment and just think about what you could do with a little bit more rigor and if I didn't have the time constraints of what was going on here. So that's what I was hoping to get across. You can have n number of containers inside of pods. You can go very, 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 it's crazy. It's really, really awesome. So that's all I really kind of wanted to show, to be honest with you. So thank you. Hopefully this is, please, if you have any questions or thoughts, you can reach out to me at Asghar on GitHub or awesome@ibm.com. So let me flip over one more time here. And then, yes, hi again. Hopefully this inspired something or at least made you think of something a little bit differently. And with that, I'm more than willing to do a deeper dive into this to show off more processes and more things like that you can do. But we started from the very ground up of what Kubernetes is and what OpenShift is, how to build containers, what the orchestration is, then went over to what OpenShift is and the guardrails that come along with OpenShift to allow you to get the velocity you look for as a developer, which is in essence what we all want. We want to get our business out to our code and our software out as quickly as possible in a safe manner. And that's exactly what OpenShift gives you. So hopefully that's great. Everyone have a good day. Reach out if I can, or if you can. Bye.